All right, on this one, the key concept here is that the negative charge over here is closer. Let me change colors real quick. The negative charge is, let's see, there we go. The negative charge here is closer to the positive charge, which makes this force vector here larger. And a big piece that a lot of people miss is that we like to say opposites attract, which is true, but we also kind of neglect this positive charge over here because this is a positive charge, and they're still repelling with this positive charge, these positive charges over here. The key is though is the distance. If you take a look at this negative charge here, we get a negative charge of distance that far away from the positive charge, and if we look at the positive charge, we get a distance of that big, which is about twice as big. So since it's about twice as big, the force is going to be less. And so why is the force less of the traction? Why is the force of attraction larger than the force of repulsion? Well, it just has to do with this distance right here. This one is shorter, which makes it stronger than this one, which is longer and makes it weaker. So that's the key concept I was looking for there. Let's jump to the next problem where below there's a diagram here. And so you're going to have to, I'm going to give you either a positively charged object or a negatively charged object, which is represented by the thing I just boxed. So this is a positively charged object. And to the right here, this is after it's been polarized. So you can see the negative charges have all been moved to the left, and they're all lining up like that. So we have polarization happening on the atomic level. This is, of course, an insulator because of the little circles around the atoms. So that is my neutrally charged object, which is polarized. And the question here is asking, why do the two objects, why are they attracted to each other? And again, it's just applying what we just talked about in the other one. The positive charge is here. If this is a positive charge on this object, it has to do with the distance here, and that's really what I'm looking for. That distance is smaller than this one. So if I'm going to on my quiz, what I'd love to see is let's say I draw a diagram of my neutrally charged object. I would like to see a larger attractional force than a repulsion force, because of the difference in the distances. So just to think about some of the points, what I'm looking for, number one, I'm looking for the fact to talk about the distances. Number two, I'm looking for a discussion of how those distances affect the force. And number three would be awesome to see is to say, well, the net force, if we're going to add this vector and the left vector and the right vector together, you're going to get a net force to the left. So that would be the third thing I'd love to see is the F net is going to be towards the charged object, which is going to attract the object. So if you can say those three things, one, talk about how the charges of distances are different. Two, talk about how that affects force. Three, talk about the net force. You can then sum that all together to say, well, they're going to be attracted to each other. Hopefully that was helpful. If you have any questions.